Welcome back everyone to this lecture on series with pandas. So a series is the basic building block of pandas, and it's going to look a lot like a NumPy array. Essentially, it just holds an array of information organized by an index. So recall that a NumPy array has data organized by an index, which is very much like a Python list, except NumPy had that additional capability of broadcasting operations element by element. So this is what a typical NumPy array looks like if we just think about the structure. There's some index starting at 0, going on all the way to n number of rows, and then we have data. However, when dealing with real-world data, we often want to organize by an index that we can directly interpret. So that's where the Pandas series comes in. So a Pandas series is built directly on top of a NumPy array. The differentiating factor between a NumPy array and a Pandas series is that a series can have a named index. So it will still remember and recall information based off a numerical index like 0, 1, 2, 3, etc. But it has a named index that then you can call data directly off that named index. That's going to be really helpful because people in general think better in terms of categories and names than just some random integer for the index. So it's going to be a lot easier for us to kind of query our data and ask, hey, what is the data point for Chicago? And in this case, that data point stands for population. Okay, so that's really the main idea behind a series, is that it's extremely similar to a NumPy array, but we'll see how we can actually have a named index and call values based off that name. So let's go ahead, open up a Jupyter Notebook, and explore series with pandas. All right, here I am at my Jupyter Notebook. I'm going to begin by importing NumPy as NP in case we want to use it to create some data. And then I'll also import pandas as PD. And then we're going to go over just a couple methods to create a series. Kind of like when we were learning about NumPy arrays, we learned about the different ways to create NumPy arrays. Let's learn about the different ways I can create a series. So to begin, I'll create a couple of just normal Python objects. I'm going to create a list of labels. So it's just very simple, a list ABC. And then I'll create another list called myList, and this is going to contain some data points, 10, 20, 30. And then let's also create a NumPy array, and we can do that simply by casting that myList object into a NumPy array. So here we have that array. And then finally, I'm also going to create a dictionary. Typically, we're not going to be using dictionaries as methods of creating series or data frames, but it is quite useful just for kind of playing around and quickly making a series. So I will show you this last technique as well. Let's go ahead and say C, and then give it a value of 30. Okay, so I have two lists, labels and my list. Then I have a NumPy array, and then I have this dictionary object with key value pairs that happen to match up to labels and my list. Okay, so let's talk about how we can use NumPy arrays and how we can use Python lists. If you call pd.series and then hit Shift-Tab, you'll see the documentation string and the init signature. And basically, there's two main things to notice, is that a Pandas series takes in data and it takes in an index. Let's go ahead and just pass in data, and we'll ignore index for now. So data is what we actually want to hold as data in the series. So I can say data, and I can pass in my list, a normal Python list. And note what Pandas is going to do. It's going to automatically show you the index that matches up with the data. So index at 0 is 10, index at 1 is 20, index at 2 is 30. And so far, this isn't really showing us anything new. A Python list operates the very same way, and so does a NumPy array. And in fact, we can also pass in, if we say PD series, and we don't need to say specify data is equal to, I could just pass it in as the first argument. I can pass in that NumPy array, and it also accepts it in just fine. There is a slight difference as far as the data type, 64-bit integer versus 32-bit integer, but for our use cases, that sort of precision doesn't really matter, especially of integers. So right now we saw that if we just pass in raw data, Pandas will automatically show you the index that goes with each of them. But recall that when we did Shift-Tab here, there was an additional index parameter. So let's go ahead and add that in. I'll say index is equal to, and I'll go ahead and say labels. And because I'm using a named parameter, let's go ahead and make the first one a named parameter as well. So I'm going to pass in my array as the data and the labels as the index. And now when we see our series, we get back a named index which is really nice and really convenient because people typically tend to think of indices as names. So I can think of A as factory A or company A, and then company B, company C, and then maybe these are like output numbers for each of those companies or each of those factories. And that's going to be really useful, especially when we begin to combine series and build them up into data frames, which we're going to learn about in the very next lecture. Now, something additional I want to point out is your data doesn't have to be numerical, and it can actually be mixed data type. So for example, I could say pd.series and say my data is equal to this list. Maybe put 10, the letter A, and then 4.4. And Pandas is going to have no problem with that. It's just not going to be able to store everything as the same data type because I have an integer, a string, and a floating point. So keep that in mind that your data doesn't have to be numerical. It can be mixed, or it can just be all strings. So for example, we can make these other values for strings, and it'll still work just fine. All right, so we have our data in a series, and we understand now that a Pandas series is essentially a NumPy array with a named index for convenience. So let's actually talk about using that index in a more realistic manner. So I'm going to create and assign a variable as a series object. We'll say pd.series, and we'll go ahead and say the data is 1, 2, 3, 4. And then we'll say the index, and let's just give some historical countries here. We'll make some countries that participated in World War II. We'll say USA, Germany, USSR, and let's have Japan. So here's my series 1 objects. It's a series, notice with a named index. So if I actually wanted to grab information from the series, all I have to do is say the name of the series, whatever variable I assigned, and really similar to a Python dictionary, I can just call it with square braces and then pass in the name of the index location, and it returns back the value. So this is why it's a lot nicer to work with a Pandas series than trying to organize this sort of information in multiple NumPy arrays. Now let's imagine I have another series. So let's create another series. We'll say pd series. We'll go ahead and have kind of similar data, just some random numbers here. And then we'll have the index be equal to, and we'll have it be all the same countries except for one of them. Let's go ahead and replace USSR with Italy, and then we'll keep Japan the same. So now I have these two series. So I have series 1 and series 2. And what's really nice about this is you'll notice that I'm missing one index name from the other. So I have USSR on series 1 and I have Italy on series 2. So what I can do is Pandas can actually perform operations with multiple series. So I can say grab series 1 and add it to series 2. And Pandas is smart enough to perform operations based off the named index. So when I say series 1 plus series 2, it's going to add where there's actual matches, and then it's going to leave not a number where there was essentially a missing match, because you're essentially saying not a number plus 5, well, that's not going to be a number, so Pandas went ahead and filled it in as not a number. And later on, we're going to talk about more sophisticated ways to deal with this, or if you want to treat not a number as 0 and then get 5 there. But for right now, just keep in mind the idea of being able to perform operations on a series, and that the operation is performed based off the index position. Something else to keep in mind here is you notice that upon performing this operation, everything turned to float. That's very typical of working with NumPy or Pandas-based objects, and it has to do with something that used to be true for Python 2, but it's actually no longer true for Python 3, is that you would lose precision in Python 2 if you didn't convert things to floating point. So it's really just a relic of the past, but keep that in mind. You typically, if you ever perform any sort of arithmetic operation with Pandas or NumPy with two integers, most likely it's going to convert it to a float on the back end. And for our use case, that really has no effect on us. It can be an integer, it can be a float, especially when dealing with time series information. So just keep that in mind. Don't be confused if you see everything get translated to a float all of a sudden. But that's really all we need to know about series. The main point to drive home for this particular lecture was really just this idea that when you're creating a series, you have the data and you have an index, and you can choose what index labels or names there are. So as long as you understand that, you pretty much understand this lecture. So coming up next, we're going to begin learning about data frames, which is really where we spend a lot of our time in this course. Thanks, and I'll see you at the next lecture.